Okay, so now we're talking about heat capacity. If we plot the internal energy against temperature, the slope of the tangent to the curve at any temperature is called the heat capacity of the system at that temperature. All right, so we've got this plot of U and T, and we've got two tangents at points, or tangent lines drawn at points A and B. So we're saying if we measure at constant volume, we see that the internal energy varies with temperature. Okay, so we're going to write CV. What does that mean? C with the subscript V is how we write the heat capacity at constant volume. And we're saying that CV is equal to the partial of U with respect to T. So the partial of the internal energy with respect to T at constant V is our heat capacity. So that we can say if we're writing infinitesimals, we can say that du is equal to the heat capacity multiplied by the infinitesimal for t, dt, at constant v. But if we want to make a measurement, we can look for a range of temperatures at which the heat capacity at constant volume CV is independent of temperature, and we can measure delta U from delta T. And we can use this relation that delta U is equal to CV multiplied by delta T. And at constant volume, we can also write that Q, remember Q is heat, the Q at constant volume is equal to CV multiplied by delta T. And we said that because at constant volume, delta U is equal to Q. Okay, so we're just writing QV, Q with the subscript V, to denote that this is all happening at constant volume.